is your positive, this is your negative. So this negative will be going with positive, and dialkyl cadmium you will get R2CD, because this is in +2 and this is in -1, so R2CD, and B will be basically this positive will be going with this negative. So what you will get, Mg X is there, MgClX, something like this, two moles of this you will get. So concentrate on this R2CD. So if you are going to react with the R2CD, already same for you are going to follow the same thing, as you know that this is positive, this is negative, okay, and this is negative, this is positive. So this will be R2 means what? Wait a minute, what is R2? What do we have? R2, that means this part. This part is I'm going to show you CH3, CH2, CH2 whole twice and CD. And after reacting this with CH3 C double bond O, Cl, what you will get? Negative, positive. So basically this is positive, this is negative. So this negative will be attacking on this. So what you will get? CH3 C double bond O is there. C double bond O is there. And then comes your CH2, CH2, CH3. Is that clear?
Sir, how do we determine what is R? I mean,
R means what? R means C, this one, this alkyl group. Mg is same MgX, and before that all is R, right? In the reaction, I
okay,
gave you 2 moles of that. That is already understood. Okay,
okay, sir. Yeah.
Austin. Let me know when you are done with this.
Done, sir.
Very good. Now we are going to have the next method of preparation of ketone. So here comes the second one, which is from nitriles. From nitriles. Now you can see nitriles, as you know that is usually triple bond N. So what happens basically when you are going to treat this nitrile or cyanide with Grignard reagent? and then you are going to do hydrolysis, then you will get your ketone. So here is your nitriles, or you can call it cyanide. So CH3, CH2, C triple bond N. And then again, what you are going to do, react this with Grignard reagent. So I'm going to take this Grignard reagent, C6H5, MgBr. This is your R. R means alkyl group, that is benzyl. And this reaction should be continuing in ether because Grignard reagent is very reactive. Now, what will happen? Very simple here. What will happen? One of the bond will be broken. Now, as you know that nitrogen is more electronegative, negative, and here it is positive. Okay, and here you can see this will have positive and this will have negative. This negative will be going to carbon, and this positive will be going to nitrogen. So what you will get, very simple, it is CH3, CH2, and then C is there, and you can see one of the bond broken, so this becomes double bond, and nitrogen. With nitrogen, what comes? MgBr, and with carbon, what comes? That is your C6H5. Are you getting my point? Now, after this, what you are going to do is hydrolysis, so reaction with water. So this is what you will get, and this whole part will be eliminated, and there will be addition of an oxygen, and it will convert it into ketone. Are you getting my point? And this has a name. I'm going to write the structure. Very famous structure it is. There is a benzene to which a ketone is connected directly in this way, C double bond O. And this, oh, wait a minute. Okay. After this, there is CH2 and then there is CH3. This has a IUPAC name, that is 1-phenyl propanone, and this is a common name as propiophenone. Propio. This is your common name and this is your IUPAC name. Is that clear?
Yes, sir.
Please do write. Are you done with this?
Yes, sir.
Very good. Now let's move to the last preparation of ketone, and then we will do some questions. So here comes the third preparation, and that is from benzene or substituted benzene. And this reaction is known as basically Friedel-Crafts reaction. If you have seen in another other chapters, Friedel-Crafts acylation will give you ketone definitely. So basically, whenever a benzene or substituted benzene is going to react with acyl halide or acid chloride in the presence of anhydride AlCl3, which is a electrophilic substitution reaction, there will be generation of an electrophile which will attack on the benzene. Let's say this is the situation. This is your benzene. And if you are going to use either AR, that means benzene, or RC double bond OCl in the presence of anhydride AlCl3, there will be generation of an electrophile. Electrophile, like you will either get C double bond O positive or this. Okay, at the place of R, there will be AR. So what will be the product? So this electrophile will be attacking at any position, and you will get like this, either this or this. And you can say this group is what? Ketone. And this reaction is what? Friedel-Crafts acylation. Please do it. Let me know when you are done.
Done, sir.
Very good. Now going to give some questions which is related to the previous chapter as well. That means alcohol. Let's see how many questions are you going to solve. Any answer? Are you done with this, Austin, Humam?
No, sir.
The first one, Humam, what did you say?
No, sir, I'm not doing.
Okay, see hexane one also. Do you know this is your hexane one all? 1, 2, 3, 4, 5, 6, and this is your hexane one all, which is converting itself into hexanal. That means 1, 2, 3, 4, 5, 6. Aldehyde. Okay, so see what happens, which reagent you are using. So you can see this is your alcohol and it is a 1 degree alcohol and this is converted into aldehyde. You know that 1 degree alcohol is converted into aldehyde with the oxidizing agent, and we use mild oxidizing agent for this, which is we can use easily PCC. PCC is pyridinium chlorochromate. Okay, so write it. Let me know when you are done with this.
Done, sir.
Okay, second one, can you do it? Austin, Umam,
I'll
Umam, any
try.
answer? What did you say?
I'll try.
Okay. Okay, so see cyclohexanol, that means cyclohexane, you are going to make it like this. And cyclohexanol is this. And converted into cyclohexanol. So that means this will be like this. So this is your 2 degree alcohol, which is converted into ketone. So see what happens here. You are using an oxidizing agent. So you can easily use anhydrous CrO3. Do the rest. If you're not able to do or not able to remember the reagents, just let me know. I will explain it. The reagents, you have to remember it. Very important. The reagent changes the product. If you have kept the reactant same and changes the reagent, the product will also be changed.
Sir,
Yes.
so I'm not getting which oxidizing agent I should apply.
Oh, see, when you are going to study the chemical reaction of alcohols, in which we used different types of oxidizing and reducing agent. An oxidizing agent is the one which will oxidize a particular reactant, but it depends upon that its strength as well, how much oxidizing nature it has. Like if you are going to solve the third one, first of all, you write the reaction. Like p-fluorotoluene is there, that means paraphenol, sorry, parafluoro. So fluoro, I'm going to keep it here, and this is your, now it becomes toluene, right? 2 parafluorobenzaldehyde. So this is the scenario you are going to use. This CH3 converted into CHO. So now you can see this is oxidized, right? Yes or no?
Yes,
Methane to aldehyde, methyl to aldehyde, it is oxidized. So what you can use is very simple. You can directly, no, let me check it. P-fluoro-parafluorotoluene to parafluorobenzaldehyde. Okay, so there must be a reagent which can oxidize it, and the reagent is very simple. You can use CrO3 in the presence of acetic acid or CH3C OOH. Acetic anhydride, basically, not anhydride, acetic anhydride. So very simple it is. Is that clear?
yes,
So, or you can use other like wait a minute, I'm gonna show you. The preparation of aldehyde from hydrocarbon. If you remembered that we did this in the previous class, this is your toluene in which we use CrO2Cl2. So what we got this part CH and here OCrOCl2 whole twice. Do you remember after this we did hydrolysis? So you got directly what? You got directly CHO. Yes or no? This whole part eliminated. Are you getting my point?
yes, yes, sir.
From toluene to benzaldehyde, and fluorine is this is your toluene. If you can use fluorine here, so it will be the same. Fluorine, you are just going to take this one and followed by the same same thing. Austin, what about you?
Yes, good.
Any answer for the fourth one?
No, sir.
No answer for okay. So this is also very easy. You can see double H you can use easily. Did you revise the last lecture, Humam?
Yes, sir, I did.
This is your ethane nitrile, and if you remember, we used double H to reduce this into ethanol. I'm gonna show you previous lecture, and this is your previous lecture. See, from nitriles and esters, we used as well. Stannous chloride you can use, or either the alternative is basically double H you can use. Are you getting my point?
Okay, sir.
So you can directly use that as well. Like if you have ethane nitrile, so double H you can directly use. The after that one, which question is this? This is the allyl alcohol to propanol. So that is also allyl alcohol. This is again what you are going to what we are going to use is very simple. You can use PCC alcohol into aldehyde, and the last one is your alkene. It will be, I think, butene 2-ene and ethanol that will be converted with the help of ozonolysis. Okay, from ozonolysis, I now able to remember. I gave some homework to both of you, and you did not submit. Both of you. Why you didn't submit?
Sir, I forgot to save the questions. That's it.
You forgot to save the question. So basically, I told you in NCRT, you have NCRT, right? What about you, Austin?
Sir, exams.
Okay, exams are over now, right? Yesterday your exam is over. Okay, I'm going to give some questions from class 11th. Let's see whether you are able to do it or not. So let's say you have this alkene. You are going to react this with O3 and you will get A followed by water and zinc dust. Let's see whether you are able to solve it or not. हाँ ठीक है बैठ Oh, very good, Austin. What about you, Humam? Okay, Humam, see. Okay, see, I'm going to explain. See, this reaction is ozonolysis. This reaction is ozonolysis, from where you will get, if you're going to do simple ozonolysis, you can get easily either aldehyde or either ketone you will get depending upon the uh, alkene, or you can get mixture of this. Are you getting my point, Humam and Austin?
Yes.
So see how easy it is. First, I'm going to explain with the help of the molecular structure. I'm going to write CH3, CH double bond CH2. And if you are going to react this with O3, so what you need to do, you are just going to make a home like this, a long double bond. You don't need to represent this double bond. Okay, you are going to make a home, and after making a home, break this home as well. Okay, this is simple to explain. I use this. Make a home, and after this, you are going to break this home like this. One oxygen should be with another part of alkyl, and one oxygen should be another part of alkyl, and this oxygen should be in air. And then after this, what you need to do when you are going to react this with H2O and Zn dust. So what you are going to do, very simple. What it becomes, the left part you can see, this is your CH3CHO. So you can see hydrogen, it makes only single bond with hydrogen can make single bond, and oxygen with oxygen you can see only one bond is there, but to satisfy what you need to do, double bond. Carbon should make double bond. Okay, so this is what, this is your ethanol. And on the left hand side, right hand side, two hydrogen is there, you can see, and one oxygen is there. So you are going to make a double bond. This is also aldehyde, which is known as methanol. So what you need to do, very simple, make a home, break a home, and then accordingly satisfy the bond of the carbon, you will get the answer. Okay, is that clear?
Yes.
No, sir, I did not get.
You did not get. Okay, see, Humam, if you get first write it, Humam, then let me know.
Okay.
Okay, then let me know. I'll explain it again.
Done.
Very good. See, now I'm going to again explain it with the help of example. I'm going to, let's say, if you have a question given like this, with the same example I'm going to give you. CH3, CH double bond CH2, and you are going to react with O3, then you are getting A, and after this, you are going to react this with H2O in the presence of Z and dust or zinc. Are you getting my point? This is the question, okay?
Yes.
Now, what you are going to do, Umam, is CH3CH CH2 and make a home like this along double bond. Are you getting my point? Like this. This looks like home a little bit, yes. Now, after this, what you need to do? Break this home. Are you getting my point? This is the scenario when you are going to react this O3, and after breaking home and passing this through H2O and Zn. See what you have got. This is in air. This evolved like this, you can understand. And this part you can see this is what? CH3CHO. Yes or no?
Yes.
And this is what? H2CO. That means basically HCHO. Yes or no?
Yes.
Now I'm going to give another example of this. Let's say if you have CH2 double bond CH2, and when you are going to react this O3, I'm gonna explain this in a single line. First, you are going to react with O3, and the second is H2O followed by Zn. Okay, so what will happen? CH2, CH2. Now you are going to make a home like this. OOO. It will be like this. Okay. Now after this, what you need to do? Break this and break this. So what you will get finally? See, this is what you will get. CH2O, that means HCHO, and this is also yours. CH2O, that means HCHO, that means 2 moles of HCHO. Got it?
Yes.
Please do write it.
Done.
Oh, very good. And now I'm going to give you some question like the famous question is this. You're going to do the ozonolysis. Ozonolysis for this. Ozonolysis for this. Ozonolysis for this. Please do it. I will explain the benzene. Please do the rest part. At the end, I will explain for benzene Austin. Okay.
Yes.
Okay.
Any answer? Austin, Humam, for the next two, any answer? So write the question like 1, 2, 3. I think you have done this for second question, right? Austin.
Yes.
Okay, please do it for the third. And I will also discuss the paper that you have gave the last paper. I will show you what you need to write. Basically, you write, okay, you know the concept, you know the answer, but still, I don't think the examiner will give you full marks. If you know anything, the concept or everything, if you know about the question, you should get 100% from the examiner. But if you write like this, you won't get it. And Humam, especially you, I'm talking about, there are a lot of things that you need to do. You need to work on it. Are you getting my Humam? Are you getting my point, Humam?
Yes, sir.
Okay. So just do it. I'll be coming from Boston. Humam, are you able to do the second question? Yes or no? Tell me the truth.
No, sir.
Okay, no
Third one
problem.
I
See,
did.
what?
Third one I did. Second one
Okay,
I
tell me
didn't.
the answer. What you got for the third one?
Third one, answer I'm not getting, but I got the structure. It's
Structure you got, that means you can write the IUPAC of that. Are you able to write the IUPAC of that?
IUPAC only I'm not getting, sir. I'm getting some.
Okay, have you got something like this?
Yes, ketone is there and two
Yes,
at
ketone. That
atoms.
means 1, 2, 3, right? How many carbon in the parent chain? 3. Is there any substituent? No, there is no substituent. This is your main functional group. So no substituent, that means directly jump to the parent carbon chain. How many carbon chain is there? How many carbon present in parent chain? 3. That means props. All are singly bonded, right? So N. The carbon-carbon bond is single bond, so N. And 2 on, or you can directly write propanone. On we use for ketone. Are you getting my point?
Yes, got it.
Okay, it's very simple. You know, there is a trick that you can easily use. If you have this reagent O3 followed by H2O and Zn, if this will be converted into H2O2 instead of H2O, then the trick failed because you are using water now as a reagent. And if you are going to use H2O2, then it will be something else. Okay. So if you have this, what you need to do, very simple. You are going to break this bond, add O this side, add O this side. So what you will get, propanone here and propanone here. Are you getting my point, both of you? 2 moles of propanone. Now, in the same way, you can do this, add O here, add O here. So the left part will be propanone and the right part you can see is this. This is what? This is basically, I'm going to write it from this point, CH3 and then C double bond O, and H is hidden here there. That means this will be your ethanol and this will be your propanol. Are you getting my point? All of you, both of you.
Yes, sir.
So you can do this, or else you need to understand the concept. Like if you have this as a reactant, if you have this as a reactant, what you need to do, what I told you. So if you are going to react this with O3, what you need to do, like this and like this. What I told you, don't show the double bond. O will be like this, make a home and then break the home. Okay, so what is on the left part? Left part is something like this. Okay, so this should be double bond. Oxygen, whenever there is with oxygen, what it will be? It becomes double bond. And here you can see it will be like this. I told you to make a double bond. Hydrogen will be like this. Hydrogen is hidden here. Are you getting my point, both of you?
Yes, sir.
Okay, please do write it. Let me know. Then I will explain the benzene. Let me know when you're done with this.
Yes, sir.
Both of you done? Just wait a minute, please. Okay. So can you apply the same trick that I have told you about others? Like in benzene, this is your benzene part. I need to make it a large, like this. What I told you, break the double bond, add O here and O here. And you can see alternate double bond. You need to break this as well, add O here, add O here. So I'm going to explain with the help of this. Now you can see this is your C and oxygen with the double bond O. And then again, this is your C and oxygen double bond here. So hydrogen is already hidden here, right? Hydrogen is hidden here, yes or no?
Yes,
So are you getting my point? What I want to tell you, in the same way, if you are going to break this oxygen and oxygen, so I took this and made this product. In the same way, you can took this, you can take this and this, make the same product. You can take this and this. So basically 3 moles of this, what you will get if you are going to name, write the IUPAC, ethane 1,2 diol. Are you getting my point?
yes,
So this is very easy, right? Please do the. Okay, if you have got it, can you do this for me? Follow the, do the Arjun. No need to worry about that. when I made that form OOO, that is called ozonide. That is intermediate of that. Okay. Any answer? See, it's very easy if you are going to use the trick O and O. See, so this will be something like double bond O, and the rest part will be as it is. Like the ring will be broken, the clip double bond O. So basically, this is your aldehyde because hydrogen is hidden there. So it will be 1, 2, 3, 4, 5, 6. 6 carbon is there. That means hex. That means hex, and all are singly bonded. So N and 1,6 diel. Are you getting my point, both of you?
Yes.
Let me know when you are done with this. Then I'm going to show your paper. So it was for 1 hour the paper. Are you done with this?
Yes.
Okay. So Austin, when you were writing the paper, what was on your mind? I want to know. Because you didn't answer the question number 1. What you have written this? Is this option B? Answer is option B, yes or no?
I don't remember, sir.
Did you write this B?
Oh, yeah, it's B. Yeah, that would be.
So in answer, it should not be like option B. I thought options you have written and something like that. Yeah. So basically 12 by 15 and okay, why you mistaken here, right? The question is the 7th question. Can you see the question paper?
Yes, sir.
So this is all are octahedral. That means CFSE of octahedral. So directly proportional to the strength of ligand. The most CN or CO is the having the most strength. So CN comes first, then comes your NH3, then comes your Cl. So you have written what NH3 as first. So that's why it's wrong. And also I didn't like the way you both of you have written like this, only this and directly writing in short form. It is for 5 marks, right? I didn't deduct much marks, but I really didn't get this. Directly you have written. If you are getting it for 5 marks, then you should write the configuration of manganese. Then you should write the configuration of Mn plus 3. Okay. The way I explained, like after that, you are going to write 3d4 here, and in 4 you can see you have this 1, 2, 3, 4 electron. Then 4s and 4p will be as it is. Then what you are going to do, since Cn minus is a very strong ligand, then pairing will start. Pairing will be taking place. You are going to write a sentence, and then 3d4, then you are going to show it like this. This is paired up. Are you getting my point?
Yes.
Something like that, and then D2, and then S, and then P3, like this. Then you are going to see hybridization is D2sp3, inner orbital complex, paramagnetic, and directly you have written rotate. What is this? If they have asked you the magnetic moment, mu is equal to, you are going to write again and again the formula n into n plus 2 bm, and you will get then root 8 bm. Again, you have see in like in this much you have done all of this. That is good. The concept is clear, crystal clear with you, but you should write more. Okay. Okay. Now, Homam. Wait a minute. Wait a minute, Homam. Yes. Here are you. Homam. Am I audible, Homam?
Yes, sir.
Okay. So, Homam, I wanted to ask you, this is correct. Question number 2, you have done wrong. And question number 2 is very easy. As you can see, you needed to, the color of the coordination compounds depends upon what. So basically, you know, Homam, energy is inversely proportional to wavelength. E is equal to hc upon lambda. Okay. So we needed to do in the form of wavelength. So the one which is having less energy will be having more wavelength. Are you getting my point? Yes or no, Homam?
Yes, sir.
So energy of what? Since we are studying complex compound, that means it is talking about the crystal field stabilizing energy, and that energy will be maximum. That energy will be the maximum for the ligand which has a strong field. Okay, so in this question you can see H2O is there and H3 is CN is there. The weak field ligand. Weak field ligand, that means the energy is minimum. Crystal field stabilization energy is minimum. Minimum energy, that means maximum wavelength. In the same way, are you getting my points? Basically, both the questions are same. Are you getting my point? Okay, so this is how you write, Uma. See how bad you have written. The question for seventh question is about conductivity. Conductivity is what? When you are going to, I told you there are two types of salt, double salt and complex compound, right? So the one which dissociate is your double salt, dissociate in aqueous solution. This does not dissociate inside the bracket, but outside the bracket it can dissociate. This will not dissociate. That means it will be as it is. This will be dissociated into two parts, 1 and 1. 2 ions is there. Here it will be dissociated into 3 and 1. 4 ions will be there. Here it will be 2 and 1. 3 ions will be there. The one which has more ions will be the one which is having more conductivity, right? Mom.
Yes.
So, but actually I didn't get what you have written. Like there is no square bracket. A square bracket should be there, and this doesn't have the maximum conductivity because this is in a square bracket and it will not dissociate. It will not give any ions, and if it will not give any ions, how it will conduct? Are you getting my point? Here you can see if you are going to dissociate, you will get 2Cl minus plus CrNH3 whole 5 Cl minus 2. You can see here 2 plus 1, 3 ions. Here you will get I don't know what you have written. You have there is no square bracket. There is no difference between this parenthesis. So write clearly. This is a suggestion for you. Please do write clearly. Also, you have done the same thing, but you did it more shortcut. There is no